Now let us see formula list in lines now, which is the last introduction content now. First of all, let us see what is a line now. Means how can you form a line now? Basically, a line can be formed on intersecting two planes. Let us take two planes, intersect them, whatever common area is there, that forms a line. I am showing it practically. Once see now. This is a plane, this board is a plane, and this duster is other plane, which are intersecting to each other. This is common area. This is common area between them, which is what line or not. That is the basic definition of the line. Due to this cause, in line equation there exist two plane equations. Means the combination of two planes gives what? A line. Now I am writing clearly here. Let us take two planes here. One plane is a1x plus b1y plus c1z plus d1 equal to 0. This is one plane. And other plane is a2x plus b2y plus c2z plus d2 equal to 0. Let us intersect these two planes now. That complete common area between them gives a line. That equation of the line is a1x plus b1y plus c1z plus d1 equal to 0, which equal to a2x plus b2y plus c2z plus d2. This is called as the equation of the line in unsymmetric form. In unsymmetric form, we say this is equation of the line, which gives what now? Combination of two planes, right? I mean, in the next stage we can discuss symmetric form equation of the line. That already we studied in lower classes, right? But before going to proceed that now, first of all I define a line. I am going to define a line which can passes through two distinct points. Let us take 2 points as one is A, x1, y1, z1, and other point I am going to take as B, which is x2, y2, z2. That means this is A point and this is B point. Let us join these 2 points by means of a straight line. Then what is the equation of this straight line? Equation of this straight line is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. X minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. This is a line passing through these two distinct points, right? In this line equation, these denominators x2 minus x1, y2 minus y1, z2 minus z1 are direction ratios of this line. You know, in previous concept only, direction ratios definition, I defined if these are the 2 points, what is the direction ratios of line that AB, which is what? x2 minus x1, y2 minus y1, z2 minus z1, those are denominators. I mean, in this form, these denominators are what? Direction ratios of the line, right? Okay, now, I am going to define symmetric form line equation by using above relation. If suppose some alpha, beta, gamma is a point on the line, and L comma, M comma, N are direction ratios of the line, then the equation of the line is x minus alpha by N is equal to y minus beta by M is equal to z minus gamma by N. Once again I am repeating more. The equation of a line passing through the point alpha, beta, gamma and having direction ratios N, M, N is what now? X minus alpha by N is equal to y minus beta by M equal to z minus gamma by N. This line equation is called as symmetric form line equation. In your intermediate stage now, up to here already studied equation of the line joining 2 points in 2 dimension space. X minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1. We are writing extra z axis result. And here we are using notations, direction ratios, L, M, N, and this x1, y1, z1 instead of this point we taken alpha, beta, gamma. Apart from that, in the logically there is no difference between these two lines. But this one and this one both are what now? Symmetric form line equations now. Now to proceed our lines concept in further action now, we need this symmetric form is convenient. I mean, in further stages, instead of unsymmetric form, we are going to use symmetric form only, because symmetric form is comfortable for one for you, right? If suppose anywhere they given unsymmetric form line equation, we have to reconstruct that unsymmetric form to symmetric form. After that, we can proceed different concepts over that line, right? I mean, in this line, this is the major line equation. Symmetric form is the major one, which is what? X minus alpha by n equal to y minus beta by n equal to z minus gamma by n. In the next step, I am going to define general point on the line. This is very important concept from unit 2 onwards. Without this condition, in unit 2 and unit 3, we are not going to do single point. We are not going to define single point without that general point condition. For that, first I want to take this line equation. What is that? X minus alpha by n is equal to y minus beta by n is equal to z minus gamma by n. Basically, this is equal to this is equal to this, means all these must be equal to a non-zero real number. For my convenience, I am taking it as lambda. Let us take it as lambda, right? By using this one, this relation, write x value, y value and z value. To write x value, let us go for x minus alpha by n equal to lambda. From that we define x. What is that x? Alpha plus lambda n. And then define y by using this relation. Y is equal to beta plus lambda n. And this equal to this implies what is z there? Gamma plus lambda n. This is a general point on that line. General point means what? Anywhere on that line. If you can give one value, fixed value for lambda, you get somewhere on the line. Right? General point means anywhere on the line. Lambda different values you get different means all points on the line. I mean, in further stages, if suppose anywhere you want to show this line lies on some surface, there define a general point on that line, and let us go through that general point lies on that surface. If general point can lies on that surface, we say every point of this line should lies on that surface. From that we say that line should be on that surface. That's why I said that this will be the very important condition from unit 2 onwards. Unit 2 onwards, this is very important relation. Next, see angle between two lines. I want to take two different lines as like this one. First line is x minus x1 by l1 is equal to y minus y1 by m1 is equal to z minus z1 by m1. First line is what now? X minus x1 by l1 equal to y minus y1 by m1 equal to z minus z1 by m1. This is one line. And other line is, second line is x minus x2 by l2 equal to y minus y2 by m2 is equal to z minus z2 by l2. If suppose theta is angle between those two lines, in such case, according to your system of coordinates relation, cos theta is equal to L1 L2 plus M1 M2 plus N1 N2 whole by square root of L1 square plus M1 square plus N1 square into root of L2 square plus M2 square plus N2 square. In system of coordinates, we define angle condition in terms of direction ratios. Basically, if you can go to these two lines, here L1, M1, N1 are direction ratios of first line, L2, M2, N2 are direction ratios of second line. And if theta be angle between them, their cos theta is what? L1 L2 plus M1 M2 plus N1 N2 whole by square root of L1 square plus M1 square plus N1 square into root of L2 square plus L2 square plus N2 square. In the coordinate system, instead of L1 M1 N1, we taken A1 B1 C1. Instead of L2 M2 N2, we taken A2 B2 C2. Just notations are changed. Apart from that, same concept here we are going to use. Again, Here, when do you say these two lines are perpendicular to each other? These two lines are perpendicular to each other if N1 N2 plus M1 N2 plus N1 N2 is equal to 0. If L1 L2 plus M1 N2 plus N1 N2 equal to 0, then we say these two lines are perpendicular to each other, because whenever these two are perpendicular, theta becomes what? 90 degrees there. Whenever theta is 90 degrees, cos 90 degrees is what? 0. Do cross multiplication, you get this one. Already we defined this in a coordinate system. Similarly, let us go for parallel condition between those two lines. Parallel condition between them is L1 by L2 is equal to M1 by L2 is equal to N1 by N2. If L1 by L2 is same as M1 by L2 is same as N1 by N2, then we say these two lines are parallel to each other. This is about parallel condition between these two lines. This is the angle condition in terms of direction ratios of two lines. Otherwise you say this is angle condition in between two lines, because in the next step we are going to define angle between a line and plane. There we may get some confusion. That's why I am telling that this is the angle condition between two lines. This is about your angle relation between the lines. Now let us see angle condition between a plane and a line. Let us consider that ax plus by plus cz plus d equal to 0 is a plane. This is a plane, and line is x minus alpha by l is equal to y minus beta by m is equal to z minus gamma by n. This is a line, and if suppose that theta is angle between those two things, then there, instead of sin cos theta we get sin theta. Here in the previous line condition we got cos theta, there here it is sin theta. That is the only difference. Sin theta is equal to al plus bm plus cn whole by square root of a square plus b square plus c square into root of n square plus m square plus n square. This is angle condition between a plane and a line. Once again I am repeating, if theta is angle between this line and plane, this line and plane, in such case sin theta equal to al plus bm plus cn whole by square root of a square plus b square plus c square into root of x square plus m square plus n square. Here again see parallel condition and perpendicular condition between them. Here perpendicular condition between those plane and line B, a by l is equal to b by m is equal to c by m. Similar to previous condition, but in the previous line angle relation, perpendicular condition here becomes parallel condition. Their parallel condition becomes here what? Perpendicular condition. Just remember like that. If suppose this plane and this line are perpendicular to each other. If this plane and this line are perpendicular to each other, then a by m is equal to b by m is equal to c by m. And let us see parallel condition between them. Parallel condition between them is al plus bm plus cn is equal to 0. If al plus bm plus cn is equal to 0, in such case we say that this plane and this line are what? Parallel to each other. Simply remember like this. In line angle condition, perpendicular condition becomes here parallel condition, and parallel condition becomes here what? Perpendicular condition. Like that easily you can remember. This is about angle relation in terms of a plane and a line. Next, let us see coplanarity condition between two lines. I mean, when do you say two lines are coplanar? I am going to take two lines as like this one. First line is x minus x1 by l1 is equal to y minus y1 by m1 is equal to z minus z1 by l1. This is first line. And the second line is x minus x2 by l2 is equal to y minus y2 by m2 is equal to z minus z2 by n2. These are the two lines. When do you say these two are coplanar? When do you say these two are coplanar? But what is coplanarity condition? Means in theoretical way, when do you say these two are coplanar? If those two lines can lies on the same plane. If those two lines can lies on the same plane, then you say those two lines are what? Coplanar lines. Those two lines you can say coplanar lines. I am taking this is first line, this is second line. Just keeping arrow mark, but it is not correct. Like this you can keep and this is a plane. These two lines lies on this single plane. Then you say those two lines are what? Coplanar lines. Right? But what is mathematical expression for coplanarity? That means mathematically, when do you say these two lines are coplanar? Here it is. If suppose the matrix determinant of x2 minus x1, y2 minus y1, z2 minus z1, l1, m1, n1, l2, m2, n2. If this matrix determinant is equal to 0, then we say that these two lines are coplanar lines. Means these two lines you say lies on the same plane. Once again I am repeating. We say these two lines are coplanar if x2 minus x1, y2 minus y1, z2 minus z1 matrix determinant. Next row l1, m1, n1. Third row n2, m2, n2. This matrix determinant is 0. Then you say what now? These two lines are coplanar lines. This is the coplanarity condition between two lines. In these lines, let us see last concept now. Before going into that concept, see special type of lines now. Its name is skew lines. When do you say two lines are skew lines? Two lines which are not parallel and not intersecting anywhere now. Such type of lines are called skew lines now. Once again I am repeating now. Let us take two lines now. Those are said to be skew lines if those are not parallel to each other as well as not intersecting anywhere now. Yes, I am proceeding diagram like this. This is one line L1 and this is other line L2. Basically these two are not parallel to each other now. Right? And according to my knowledge, it is these two are not intersecting now. But if we can proceed like this now, if we can extend like this, it may be intersect now. But my approach should be like this now. I am going to show those two lines practically. Suppose this is one line flowing like this now. This is other line flowing like this now. These two are not parallel and not intersecting anywhere now. These two lines are called what? Skew lines. There I given the diagram only. I am taking this is small line. No? Reason is somewhere here it is crossed. This line is crossed here. This line. Right? Now these two lines are called skew lines. These two lines are called skew lines. By using this skew lines concept, we can proceed one special condition. It is shortest distance between the lines. Shortest distance between the lines. Yes, let us take skew lines, two skew lines. The perpendicular distance between them is called as shortest distance between them. This is one line, this is other line. I said, this line is crossing here. There, let us take distance. Calculate distance from here to here. That distance is called as what? That distance is called as what? Shortest distance between the lines. Right? Shortest distance is possible to find whenever lines are skew lines. This is about complete formula list in your lines, as well as this is about complete introduction of your solid analytical geometry. In the next stage, we can start our main syllabus.